Hey everyone, today we are going to see the static keyword in C++. So let us start. So the static keyword is one of those keywords which look simple, but it has different meaning depending on the context and where we are trying to make use of it. So what is the core meaning of static? At a high level, you can say the static has three main purposes. First is the lifetime, the second is the linkage, and the third is the class level sharing. The lifetime is the storage duration, which means that the static variable will live for the entire program. Linkage is the visibility across the files. It can be internal or it can be external linkage. So the static variable goes under the internal linkage, whereas normal variables can go under external linkage and you can access them in other files by using extern keyword. Then you have the class level sharing. So it can be shared across multiple objects if we define a static data member. So let us start one by one and look into the scopes where we define the static keyword and what do they mean. So the first one is the static keyword defined in a local scope. Say if you have a function and you have static variable defined inside the function. Now if you try to call the function multiple times, even then the static variable will be initialized once. The variable persists across the function calls. So even if we are calling the function multiple times, it will operate on the same value which was left before. It is stored in the data segment, not in the stack segment, like other variables inside the function. So in this example, since we are calling the function three times and variable x is static, so it is initialized only once, and every time it runs the increment operator. So the output goes to 1, 2, and 3. Now, this is the behavior when the static variable is defined inside the local scope. Then the interviewer might ask you that if we don't initialize it, then what will be the value if we try to output that variable? Then it will be zero. Why? Because the static variables are zero initialized by default. Then comes the global scope. If we define a variable in a global scope, then what happens? Let us take an example. I'll create a static link IOStream using namespace std. Now, if I define a static variable int x equals to say 10 or 20, now inside int main, since it is a global variable, I can make use of it. If it was in the local scope, then you can only use that variable inside the local scope only. Say if you have a function and inside this you have static int y equals to 10, you can output this variable inside the function, but you cannot use it outside the function because the scope of the variable is till the function only. Even though it is static, it will be initialized once, even if you call the function multiple times, but you cannot use it outside the function. Now, since we have defined the variable x as a global variable, so we can use it inside the int main, and you can see that the scope of the variable x will be till this file only. You cannot use it in some other file. Let us say there was a variable z which was defined in some other file. Then you can use it inside this file as well using the extern keyword, extern int z, and you could have used cout z. This was possible if the z is not static. But if the z is static, then you cannot use extern. It means the external linkage is not possible. With static keyword, only internal linkage is possible. So that was the behavior with the global variable. Now let us move on to the static data members. Let us say we have a class A and it has a static variable count. Now, since it is static variable inside a class, so it is the property of a class, not the property of an object. So it will be shared across all the objects and only one copy will exist. So it means even if I create multiple objects of A and I try to do some operation on the count variable, they all will be doing the same operation on the same memory location of the count. They will not have their own copy. Now, one important rule for the data members is that if you define a static variable inside the class, then you have to define it outside. So let us take an example for this as well. I'll create another file which is static member.cpp hash include iostream using namespace std. Now, if I'll create a class, say class student, and inside the class student, I'll create a static variable int count. Since I have declared a static variable, so I have to define it outside. So I can say int student count equals to 0. It will be initialized with 0. So if it is a data member, then I have to initialize it outside. So many of you might be thinking, why is this so? Why do we have to define it outside? The first thing is that since it is the property of a class, not the property of an object, so there is no point of initializing it inside the class. So it should be initialized outside. But but the actual reason of this is avoiding the ODR rule. So I have already explained the ODR in my inline video that if we initialize it inside the class, then if we try to include the class in different files, then it will create multiple copies, which will violate the ODR rule, which is one definition rule. So to avoid this, we can use inline. So before C++17, this was an error. We cannot just initialize the variable inside the class. We cannot do this. But after C++17, we can do this by making the static variable as inline. If I make it inline, now this is absolutely okay. Now you can see the error has gone, right? So this behavior is only applicable for versions above C++17. Now we can also use the static keyword with the function. Say if I have a function static void show. Now we just show some output, say hello. It works fine. But what is important here is how this static keyword will behave with the function. So the first point is that you cannot use this pointer inside the static function because this keyword points to an object. And since the static functions are not the property of the object, it is the property of a class. So you cannot use this pointer inside the static function. The second thing is that you can only use the static members inside the static function. You cannot use normal variables. So if you have, say, int x over here, you cannot do cout x. This will give you an error. Why? Because this is a static function. So you cannot use non-static variables inside this. You have to use static variables. So if I do count, it will work fine. But you cannot use x because it is a member, not a static variable. So this will be a property of an object, not the property of a class. Only those properties can be used inside the static function which will belong to the class, not a particular object. So you can call other static functions inside a static function, but non-static function cannot be called. The same rule applies to variables and functions. So the interviewer might also ask that if we create a normal function, say int func1, and from inside this, I'll create a variable, static int z. What if I return the z from here? Will it work? Let us initialize this since it is not a data member. So we can initialize it inside the function. Now, if I return this, what will happen? Will this compile? Yes, it will compile. And it will return a valid address as well. It will return the reference of the variable z. But if you remove the static keyword from here, then this compiles, but it might give you an error. Why? Because this is going to be a dangling reference. Because the scope of the variable z is only within the function, not outside the function. So if you return the reference of z, then the z memory will be released once the function is completed. So using the reference of z variable outside the function is actually a dangling reference. So it might cause you an error. Now the same behavior is applicable to any user defined data type as well. Say if we are creating an int z which is static, I could have also done void function 2, and inside this I can create a static student obj. Now the obj class is of type student, but it is static. So if we call the function func2, then it will call the constructor of the student once. Even if I call, say, in my int main, I'll call func2 twice. Since the func2 is called twice, but the variable is static, then the constructor will be called only once. And the scope of this object will be till the program ends. So the destructor will be called once the program ends, which is at the end of the main function. So this is the same behavior which is applicable to the primitive data type as well. But this is to show you when will be the constructor and destructor will be called if we use a user defined data type. Now comes the static and the initialization order. So there is one important point that you should always remember. So if you have a variable x, variable y, and z, they all are static and defined in multiple files, then the order of initialization is undefined. So don't use other static variables to compute some value and try to initialize some other static variables, because it might give you an error or a garbage value that you are not expecting, because the initialization order is not fixed. So any static variable can be defined in any order. Now the interviewer might also go into the concept of singleton, where we use the static keyword in C++. Let us create a file, static singleton. Now in this static singleton, I have already explained in my static video as well how we can use the static keyword for implementing the singleton design pattern. You can watch the video, but I'll explain a quick overview that it is called the Meyers Singleton. Say if we have int get instance, this get instance will be inside the class. You create a static A class, which is the class name instance, and you just return the instance. Now this is completely thread safe. So let me also define the class A. So this will be inside the class. Okay, we have to return the A reference, not the int. So now you can see that we are creating a static instance variable of type A, and we are returning that instance. So this is completely thread safe, and it is a singleton behavior. Only one instance of the class A will be created whenever we call the get instance. So before C++11, this was not thread safe, but after C++11, static variables are completely thread safe. So you can use it for singleton patterns as well. Now let us go back to the PDF and try to revise what we have seen till now. So we have seen all these concepts. At the end, we have a compiled version of whatever we have seen. The static versus an automatic variable. What is the difference? If we see the lifetime, then the static variable has the entire program lifetime, whereas the normal automatic variable has the function scope. The init is only done once for the static variable, whereas for the normal automatic variable, it is every call. Static variables are stored in the data segment, whereas normal variables will be stored in the stack segment inside a function. Now, the static keyword has different meanings. What we have seen till now in different scopes. So let us also see that if it is a local variable, then it will persist its value. So we have seen that if we call the function multiple times, only one instance of the static variable will be created and the value will persist and we can make use of that variable again and again. If it is a global variable or a global static variable, then it will have an internal linkage. It means that the variable can only be used inside the file, not outside the file using any external keyword. If it is a class variable, then it will be shared among the objects. It will be a property of a class, but not the object. So all the objects can make use of it. The same memory will be altered every time we do some processing on that static variable inside the class. If we have a static function in the class, then this pointer will not be available and only static variables and functions can be called inside the static function. If we create a global static function, then the scope of the function is inside the file only. It is only visible inside the file, not outside the file. So you cannot use the same function in other files. So hopefully you would have understood what is the meaning of static and how it can be used differently in different scopes in C++. So thank you. Do like and subscribe the video.